Stress is a force that can cause a change in a physical sense. It is a tension that is produced that can cause a body to deform. Stress can be measured and is dependent on the applied force within an area. It is a resistance or internal response of an object to an external pressure. Strain, on the other hand, is the change of shape or form of an object when stress is applied. Under applied forces, a physical body is deformed or altered. This is called strain. It only occurs when stress is present, and it is a concept that has no unit of measure. It is most commonly associated with deformation, which is what happens when stress is applied. Most objects respond to stress or pressure by changing their forms according to how the pressure or strain is applied to them.
So I will be talking about the different points of this graph to give you all some background before we relate it to human motion. As we can see here, strain is located on the x-axis and stress is on the y-axis. Both of these have a linear relationship, and the more stress on a material will lead to more strain on the material. And if the stress is not lessened or removed, it will eventually break the material, also known as failure. The elastic region is when the material is able to return to its original length or position without permanent damage, whereas the plastic region is when the material will not return to its original length when the stress is removed due to the stress being too much for it to handle. This means a slope will change its steepness based on how elastic and flexible a material is, which can be referred to as the elastic modulus, which is the little triangle in the center of the graph. The greater the elastic modulus, the more stiff the object is. The transition from elastic to plastic occurs at the yield point, which is the exact moment the material is damaged and won't be able to go back to its original length. The failure point is when the material completely snaps and the slope will actually curve downward.
One way that helps me define the stress-strain relationship in my own definition is by relating it to sports or exercise. Stress and strain relate by more strain occurring in the material caused by the stress being applied to the body. In this case, a jog completed by a runner illustrates this relationship. Every individual step taken by the runner adds stress to the body. The faster that a runner wants to run, more stress is placed on the body. Since this sprinter is experienced, she has a larger elastic region that will revert back to its original length. The yield point will be much higher in an experienced runner, meaning that this runner can add more stress to her body than an inexperienced runner before reaching the plastic region where permanent deformation will occur. The difference in an elastic modulus can make or break an athlete by either leading to victory or injury.
When the subject squats down, they are loading the body, placing stress on the lower half, causing a change in length of various muscles, which is then released when the force is applied into the ground. Since nothing was strained or torn, the muscles remain in the elastic region as the muscles return to the normal length in a passive state. Based on the stress-strain relationship, you are relatively remaining in the elastic region when running in the video. However, at some point when the subject was running, they went past the yield point, which in the human body may be slightly bending of the bone and straining a muscle. This subject went beyond that into the failure region, meaning they went beyond physiological limit. Specifically in this case, a muscle tear, as demonstrated when she held her hamstring.
The videos shown are just 3 examples of how stress and strain apply to real-world situations. The relationship models the stiffness or compliance of different materials. With every different material in the body, and even in materials outside of the body, a stress-strain graph can be created to measure the stiffness or compliance of a material. The steeper the slope of the elastic modulus, the stiffer the material is, meaning that it won't change length. The less steep that an elastic modulus is, the easier that the material will change shape, making it compliant. It gives an idea about the limits of the human body. The stress-strain model that we discussed allows people to visually see how the body is limited to certain loads depending on body type. It gives humans an idea about the precautionary steps needed to be taken, like proper form, weight, and frequency in lifting, running, stretching, or other activities. The relationship makes sport more competitive and exciting. If every athlete we saw on TV had the same stress-strain relationships in their bodies, the excitement in sports wouldn't exist. Different levels of stress-strain allow athletes to push their bodies further than others, adding that exciting competitive edge that all fans love. Plus, it gives athletes a reason to continue training hard to increase their elastic modulus to become better in their sport. The relationship between stress and strain is a biomechanical topic that models how much impact humans can place on their bodies. It applies to every aspect of movement that humans face, and models the difference between healthy movements and injury.